If you see my keynote on Monday, somebody on Twitter said, he does rapid fire again. And I'm going to disappoint you. I'm going to do that again, actually. Except that the topic is a bit smaller. Well, it is a big topic, actually. It's called microservices. Is any of you doing microservices? Why? No, I do too, by the way, so that's good. So, no. But I'm going to do, this is actually a summary of my one-day course. So I'm going to give you sort of an overview of what you will encounter if you start doing microservices. And if you're already doing microservices, that might be a good checkup to see, like, oh, you guys are doing way wrong, and we do it very differently. And I'm really curious to hear that, by the way, because there's lots of ways of doing this stuff. And not just my way, but that's the way I can present it, right? So let's start with a short introduction. This is a short definition by Martin Fowler about what microservices are, right? He says, well, basically, it's in short. So there's no, well, it's lots of stuff, basically, right? The thing with microservices, it's not just a paradigm, but there's lots of stuff that you need to take into account if you are doing microservices. Stuff you will encounter along the way, because basically going microservices is a journey. My journey has been, I've been on the way since late 2014, early 2015. I probably did the very first microservices project in the Netherlands, but, and I'm still doing it. And we enjoy it, but it also gives a lot of problems that you will encounter when you start doing this. So I'm going to try to give you an idea of what we have encountered along the way. And by we, I mean the teams I've worked with. Part of my current team is in the building. But they're probably not coming to this talk because they've seen it like 1,000 times already and they're on the slides everywhere, so they don't want to see it. So what about microservices? Well, here's the thing, right? The story I can give you is my own story. That's what I usually do if I do talks. It's from the stuff that I do in everyday life. So it's part theory, part practical. So, and this is what I'm going to try to help you go through in these 40 minutes, which is way too short, I know. So do a little bit of introduction, some of the lessons learned, a little bit about architecture, about domain, about DDD, and then we'll move on to what do you do with data, and do you need continuous delivery or even continuous deployment? Yes, you do. Do you need security? Yes, from day one. Do you need to test it? Yes, from day one. And then we'll round up, and then we'll go have some more coffee or maybe beer already, I don't know. So this is me. I'm Sander. I am, as I said on Monday, as well, an independent dad. I have 3 kids. 1.5 are living still with me, especially my oldest. She's 26, and she came back, right? That's cool. So, and I do speak a bit. I write a bit. I travel a bit. I'm basically a programmer. I've been writing code since 44 years. I discovered 2 weeks ago. And I'm currently the CTO for an e-commerce company called iBOOD, which is located on the other side of the city, basically. So I'm going on my bicycle from here to the office in the afternoon, actually. So, my team and I also indulge in open source. And open source is really lovely to do, actually, because it gives you all sorts of interesting constraints, because all sorts of people that you don't know suddenly depend on your code changes. And that makes it really hard to actually evolve your open source project, which is cool, by the way, and it's a nice experience. So I work for a company called iBOOD. We are a, let's say, a community-driven deal platform. And the goal and the strategy of the company is to become Europe's leading deal platform. And I'm sort of trying to help them to go there, right? So that's the introduction. So let's look at some cases. So this was the first case that I started to do microservices in. I got invited to become the CTO for a well-known insurance company, well-known here in the Netherlands. And I said, okay, what are your problems? And they said, well, we have on-premise legacy. They had their own mainframe. This was late 2014, right? They had their own mainframe, which was running 18 million lines of COBOL and 12 million lines of Java. Now, figure out which one is worse, but no, doesn't matter. And the problem was that their developers were, well, they were writing this. This is not only COBOL, it's also in Dutch, and it is also using lots of acronyms and abbreviations, which basically means you can never give this to somebody else and say, maintain this stuff, because nobody has any idea what's going on, except for their own developers. And the problem with that was they are aging, right? We see that everywhere in the industry is that people are, who do these ancient languages that are very much alive, by the way, they are retiring. They turn 65 or 67, whatever the age is that you retire these days, and they're not going to be there anymore. So you have to do something, right? My current client, the e-commerce company, they have a very different problem. This is basically their current platform. It is basically a set of systems that are tied together in all sorts of interesting ways. And we have to deal with that. So those are the cases that I will get my examples from, right? The first thing you need to figure out is actually the biggest thing you need to think about if you're going to do microservices or whether or not you are going to do microservices, and that is figuring out what the actual problem is. And I can tell you from experience that a lot of companies and a lot of teams are starting to do things, not just microservices, but other things as well, for the wrong reasons. Number one being scalability. A lot of companies think they need scalability, right? Because, well, you're all Netflix, right? You're all Spotify. So you need everything to be as scalable as possible, which means you spend a lot of time on scalability. Why that might not necessarily be the actual problem that you have. We didn't have that in the insurance company. We wrote our first service. We could send 68,000 requests on it on a single JBoss instance. I think in an hour or a minute, probably an hour. So that was enough. We had no scalability issues whatsoever. Every one of the services that we wrote ran in a single instance and later 2 or 3 instances, right? That's not scalability issues. So we didn't have them. So you don't have to solve them. The problems you might have might be that you have big monolithic systems that are hard to evolve, that are hard to architect anymore. So in code bases that are aging, right? So basically, if you have 8 million lines of COBOL and 12 million lines of Java, and the people are retiring, what do you do? Or one of my other clients, they had like, 9 million lines of COBOL and 2.8 million lines of PHP. Now figure out which one of those is worse. I can tell you, by the way, but, and they had like 1.9 million lines of SQL. That's even worse, I would say. But so that is terrible, right? And you cannot evolve anymore. You lose the ability to innovate, to do new stuff, to move into different markets, and you might need to do that, right? Or what about legacy systems? Not all systems that we build have the great architecture of this beautiful building, which is the Pantheon in Rome, which is one of my favorite buildings in the world, actually. You might enter up with a stack like this. This is an actual stack from one of my previous clients, very recently, actually. And they couldn't maintain this anymore, right? They had to simplify. That's why the stack was also in my talk on Monday. And then it's dependencies. Dependencies will kill you every time, right? That's the point. They will. This is a systems landscape from a big company here in the Netherlands. Every box in there is a system. That little pink one there, SAP CRM, has 164,000 tables in the database. Tables, right? Not records. Can you imagine the sheer size of this? They got totally stuck. My current client has an interesting landscape. They have all sorts of systems, big, small services, in all sorts of languages, dealing with all sorts of external parties, and then there's data everywhere, basically, in the landscape. So everywhere you go, there's data. It's duplicated, it is synced and synced again in all sorts of mechanisms, so the data is basically everywhere. Now that becomes a problem if you want to grow, right? So this is an actual problem. For most companies that I go into, and I used to work for large consultancies for a very long time, and then I went independent. I was like, oh no, I'm just going to work for small companies, because small companies have very different problems. They usually run into something which is called the innovator's dilemma. If you work for a small company, you've seen this, for sure, right? So this is the thing. So you start building a product, really nice product, it catches on. So one of my clients invented the smart thermostat. Cool device. It really worked well. So he invented that like 15 years ago, and it was cool. And they started adding features to it, and the community grew, and the amount of customers grew. And it grew up to a point in time that they started adding more and more features, like traffic information. No, I'm not joking. This is true, right? They had traffic information on your smart thermostat, on the wall of your living room, which is pretty useful if you don't go anywhere, basically. But anyway, so in the end, you get to a point where your community does not longer grow, where the model that you're executing, well, you've executed to the max. And at that point in time, if some other company in some other country using newer technology comes into your market, does the same thing or even a better thing, you're doomed, basically, because you fall into what is called the dilemma zone. And that is where you have to reinvent yourself. And this is specifically where microservices are doing well. So if you're in a company like this, where you think, we're not growing anymore, what do we need to do? We need to go to new countries, new markets, invest new business models. That's the point, right? That is where microservices help, because they help you gain flexibility and scalability. And scalability in being able to move as a company and to grow as a company. And then you see this thing called common ways law. Like a lot of organizations are actually confined to produce systems that actually copy the communication channels in your company. Which means if you are very hierarchical organized, you're running in silos that don't talk to each other. As a result, everybody's sub-optimizing for their own department. People don't talk to each other, right? And this is constraining you to grow further. So this is an actual problem. And the question is, what are you going to do? Well, what are you going to do? Microservices, of course, right? Not necessarily. The thing you need to investigate is microservices is not a done thing. It's not like I'm going to do microservices, let's install 50 of them, done, right? It's not PowerPoint. It's like, this is really tough stuff. And you need to realize that you need to learn all the time. That's the only thing that is for sure if you start to do microservices. And learn by doing it. It's basically the Nike approach, right? Saying just do it. Go out and do it. And you have to find your own way. There is no predefined path in this. Every solution in the microservices architecture, every one I've seen quite a few, they're totally different from each other. So I can only tell you ours, right? So there's a whole bunch of lessons to learn from that once you start moving in that direction. And I've put a list on it. So this is not the total list. This is about half of it, I would say, of the stuff that you could point specifically to things that we've learned in the last, say, 8 years that we've done this stuff. So I'm going to show you a few of them. So first of all, it is really essential to have a strategy, to have a sense of direction. Now, the next slide is not going to show up nicely because I'm running on an ancient laptop, so my laptop has a bug and doesn't want to connect to the AV. So I'm using a real old laptop. It doesn't have all the fonts that I have. So basically, my current client is a web shop. They say, the current system says, one shop equals one country, so one language. So that means the German shop runs in German, only in Germany. The Dutch shop runs in Dutch in the Netherlands. Also in Belgium, by the way, but we act as though it is Belgium. So if you're Belgium, sorry, we are going to move into Flemish and stuff and French. And that's a problem, because it limits them to grow into other countries. So their strategy is becoming to say, no, we need to cut that loose. We need to separate shop from country, from language. So we can run the Dutch shop in English, or in Arabic, or in whatever, right? And we can run the Belgium shop in French. Or go out into France or Italy or wherever we're going to go, right? And that requires a big change, because we need to change the model. Not just have one shop, but have multiple shops in multiple languages in multiple countries. Which is a very different problem. And that is a problem that we are trying to tackle to work on, right? And to do that, we need a single source of truth of all that data. So remember, all that data was everywhere. We need to have it in one place. So we're going to build a set of services, or we are building a set of services that actually do that. And that we have a single source of truth for what is an offer, what is an order, what is a customer, et cetera, et cetera. Those are becoming our microservices. And on top of that, so this is the slide I'm selling to the management team all the time, so we're going to build this platform that allows you to grow into wherever you want to grow. Not necessarily everywhere, but so that's the thing. You need to define a strategy. You need to have clear business goals, right? And you need to have a very clear picture before you start traveling on this journey to see what problems you are actually solving for your organization. And to figure out in a very abstract way, how are you going to get there? What are you going to do? Not very detailed, because that wasn't work in our industry, but at a high level, figure it out. Create a sort of abstract roadmap, and then start solving one problem at a time. Because the only way forward in doing this is taking really, really tiny steps. And the reason for having to take tiny steps is that you cannot build a big system all at once. I heard a story yesterday. I was at a barbecue, and there was a guy telling a story. He said, well, this particular company, it's a car company in Germany, by the way, they had to redo all of their software. It's a well-known, I actually drove their cars, by the way. And they started the big project with 4,000 developers. Where they got 4,000 developers from, I really have no idea. And they took 4,000 developers and they defined one big project to replace all of the software of their cars. Can you imagine what happened to the project? It failed. Wow, what a surprise. The problem is you need to start taking small steps. Otherwise, you can never go forward because of this. This is the Cynefin framework. Have you seen this before? You should, right? This is important stuff. So if you are on the right side of this diagram, maybe this thing works, so in the complicated zone or in the clear zone, that means that there is either a best practice or a set of good practices that you can follow. If you follow them, you'll be all right. So this is plannable. This is manageable. This is what managers think that you are doing, actually. You're not, because most of us are either in the complex or in the chaotic zone. Being in the complex or chaotic zone basically means there are no good practices yet. So if you start doing microservices with everything that comes with it, there is no set of best practices you can just apply and it works. You need to figure out those. They need to emerge. And the best thing to help that doing is have a strategy, have a sense of direction, right? If that's true, then you're in the complex zone. If you have no sense of direction, you're in the chaotic zone. That's even worse. Now, getting out of this, there's only one way out of this, and that is taking small steps. So the best way forward in the whole of software development would be to take small steps. So I'll give you an illustration again of my current client, right? So when I got there, they were really highly siloed. They didn't talk to each other. And then I figured out, well, to be able to grow, they need to start talking to each other because they need each other to actually run all their business processes. So I figured, what if we could do an inverse Conway maneuver? That basically means that you turn it around, right? I said earlier that organizations build systems that sort of match their communication structures. What if you would build different systems that would change those communication structures? It actually works. I've done it, actually. And I'm trying to do that here as well, basically allowing us to break through these silos, get these people in collaboration mode in the company, and thus being able to grow in directions that we haven't seen before. That we also don't know yet what those directions will be. But because we can put the brilliant minds of these people together, we can actually do more. So that's my goal here at this client, right? So that's nice. So architecture, that's the next point. So we need to talk about architecture a little bit, right? So, and this is a brilliant quote from Neil. Neil says, an evolutionary architecture supports continual incremental change, which matches very closely to the small steps that you need to take. And it does that as a first principle. So your architecture does always need to be changed. It needs to be sort of resilient against whatever comes at you. You need to be able to fit it into whatever comes at you, which is different than building it 16 layers and then getting totally stuck. I once worked for a bank. They had an 11-layered architecture in Java, of course. So I'm not going to joke about Java too much actually today, but and they got totally stuck. They couldn't build any software whatsoever. It took them like 4 months to build like one feature, basically, because yeah, well, some architect, of course, with elbow patches, because that's what architects have, right? They have elbow patches on their codes, and he invented it. He never had written any lines of code, and he said, well, we need all these 11 layers of abstractions. I'm like, what? Didn't work, basically. So that was not a good evolutionary architecture. You need to go into a direction that your architecture becomes adaptable to what you're doing. And that is extremely important if you start doing microservices, because when you are doing microservices, you have lots and lots of different repos with lots and lots of different pipelines. And if you have, I think we now have 90 different repos at this point in time, but it will grow into like 200 probably. 200 different repos, all with code in it. And it helps if they look a little bit alike, so you can let it evolve. So I'm going to give you this example, which I already gave on Monday, so maybe it sinks in now, because I know I talk way too fast. And I'm not saying to use this architecture. It's just an example of the architecture that we use. And it kind of works, because it has evolved over the past 20 years, and it's still there. So it must be able to evolve. So this is a screenshot of a part of our repos. These are our services, and we have another one that says, oh, there's more services, and it's growing, actually. It grows by the week. Any one of these small repos has the same structure in code. They follow sort of this particular architecture. So we say at the heart of it, and I'm going to talk about DDD a little bit later, is the domain. So the domain is defined in entities, value objects, enums, structs, sort of that stuff. You always build everything, every piece of software that you build with the domain at heart. Whether that's a small application, whether that's a mobile app, whether that is a service, always do this. That's the one thing I try to advise to people. On top of that sits the repositories and the factories. These are all patterns coming from the DDD book, right? So, and from Fowler's enterprise, Patterns of Enterprise Architecture book as well. On top of that, we have use cases. You may not have them. We have them because we have a model as well that's sort of a high-level abstraction model of all the functionality that we could figure out so far. So we have actually a picture of the overview, which is often, well, sort of missing in investments in microservices. You have all these services, and nobody knows how they act together. We do, because we have a model for it, and Wouter's maintaining that. So, on top of that, we have the resources. So basically, these are classes where the HTTP request comes in, it's handled by the rest of the code, and it bubbles up, and it handles it, and it puts it back into a structured piece of JSON. So that is a basic architecture, and of course you need to go out. So you need to go out to other services, other data, external services, if you're a facade or an adapter, and those sit at the bottom of the architecture. In code, it looks a bit like this. This is a resource class. So this one actually listens to this particular URI. We have URIs in code, not in text. Please don't write your URLs in strings, because you get in the same problems if you have SQL statements in strings as well, right? So it listens to this URL, it has a get endpoint, and then it has a simple line of code, which goes on to be executed by the use case. The use case is actually this piece of code, and it has some methods, not a lot actually. By the way, this is all in TypeScript, but I like TypeScript because people from the OO paradigm can read it, and people from the FP paradigm can read it as well, and write, by the way. So this is a use case. It handles process logic, basically, for us. And then there's the repo, which is one level deeper. So the use case uses a repo or a set of repos, and it has a bit of functionality. Most of it is actually defined in the framework that we use, which is open source. So, and then there's the gateway, and the gateway helps you to go out to wherever you want to go. In this particular case, it's a Mongo gateway, which means it will talk to a Mongo database with a products collection in it. And well, this is all the code basically that we use for it. So it's an architecture that has evolved, because I was using the same architecture 10 years ago when I was doing .NET, and 15 years ago when I was doing Java, and 20 years ago when I was doing Power Builder, 25 years ago probably. Have you ever done Power Builder? That's only for old people. Yes, sorry. I reckoned you would have done that, so sort of. I don't know why, but it's so this is our basic architecture. Now, then we need to talk about the domain, of course, right? And I'm going to touch on a bit of these old patterns that we have in this industry. And it's really cool that me as an old guy, I'm probably older than most of you, with some exceptions, and I have no idea how old you are anyway, but so with some exceptions, but I've been in this industry for quite a while, which means I have read books that are not published anymore. They're hard to get, by the way. But this is nice, right? This comes from, what's the book called? It's a book by Beam and Constantine, and it goes on about coupling and cohesion. And what they basically say is, what you really, really want, is high coupling and low cohesion, and not the other way around, which means don't structure yourself in a way that you have all your whatever repositories in one place and all your entities in another place and all your whatever classes in another place. That really doesn't work, because that means that if you have a large application with 4 layers in it, that everything depends on everything, which gets you totally, totally stuck. One of the guys on my team used to work for a company like that, and I used to coach them way back, and they had like I think they had like 1,000 tables in the database, so they had like 1,000 classes on top of it, and they had 1,000 repos, and there were SQL statements everywhere, and they got stuck. Company doesn't exist anymore, right? That's the thing. What will happen if you do low coupling and high cohesion? Your company will die, basically. So you need to put it in a different structure. You need to put the functionality together that belongs together. So my repo sits here with my entities, with my gateway. That is how you couple it, because that does a piece of functionality, and it has a very low cohesion to other ones, which means I can evolve this one without evolving the other ones. And this was written down in the late 60s or early 70s. Microservices do exactly this, or they intend to do this, right? So if you move on, we got Unix. Unix says, write programs to do one thing and do it well. Exactly the same, right? They probably had they read the book as well, I guess, right? And if you go on, you come into Bob Martin's paradigms, right? You go into Solid. You all know Solid, right? The one I like the most is this one. It's the single responsibility principle, because it actually follows the same structure as the ones I showed you before. So he basically says every module, whatever that module is, so that's why I put it in quotes, should have responsibility over a single part of the functionality, not over a layer of repositories. So again, these are vertical cuts into your architecture, into your code, right? And this is how you split stuff up. And it goes on. He says, group things together that change together. So what changes together? It's the stuff that makes this part of functionality work. It's not the 1,000 repositories that work together to get something done, right? You need a factory, a repo, a use case, some UI, et cetera, et cetera. That is the unit that you're looking for all the time. And that means you can make it smaller. And then we get into DDD. And the funny thing is, DDD says exactly the same. You've all read this book, right? Without falling asleep. Now, it's actually really, it's a great book. It's one of the most important books in this industry. It's a bit hard to read, though. So I'm going to give you the 5-minute summary, right? So you can all go home and say, I know DDD. Put it on your CV, on your LinkedIn profile, you get hired much more. Well, you get hired anyway, right? But the market is good. So anyway, so we'll start off with this thing called a bounded context. And the truth is, when I read the book, when it came out in, 2005, 2006 or something, I didn't really get this thing. I only turned back to this particular pattern when I started researching microservices. Now, Eric says, when you model larger domains, it becomes progressively harder to create this single unified model. You all know that, right? The bigger your database gets, the harder it is to maneuver it. And then he said, instead of creating a single unified model, you create several, and they're all valid within the bounded context. Now, there's one pattern that goes with this. Unfortunately, I did put it on the slides, but it's called the ubiquitous language. Now, simply put, a ubiquitous language is a language in which everything has a single meaning. And that is crucial to using bounded context. Because, I'll show you an example. Imagine you have this really huge data model, right, with thousands and thousands of tables being procurement on one hand and sales on the other hand. This could have well been the model for my current company, right? Now, the problem here is the product thing, whatever it is, a class, a module, a service, because it is part of the procurement stuff and it's part of the sales stuff. That means, normally, if you would put it in one model, it has all the properties and all the behaviors of both of these domains, or subdomains, or whatever you want to call it. And that's where you don't have a ubiquitous language, because it has different meanings in different parts of your domain. And as a result, you could split this up. So these are two bounded contexts, one for procurement, one for sales, that each have their own part of the product. And then you think, yes, but there might be a link. It's the same thing, right? Well, not necessarily. It depends on the context. But the link between them is very thin. Think high cohesion, low coupling. Or the other way around. Always forget the ones which is which, right? So this is basically, again, the same thing. And then I started investing it in 2015. I was like, yeah, it doesn't really match, because they're still quite big, actually, because things you can define in a ubiquitous language in a single bounded context is still a really big thing. It's not fit to be a microservice, because microservice you want to have to be scalable, right? To be able to spin up 1,000 of them in about a second. Currently we're using Google Cloud Platform, and our services spin up so fast that the database cannot keep up. That's really cool, actually. Well, it's a problem, but it's really cool as well. So the next step is, you need to read the next pattern in the book. And the next pattern is the aggregate. Now, the aggregate says, an aggregate is a group of associated objects which are considered as one unit with regard to data changes. You might think, hey, a transaction. True. You could look into this as a transaction. So it's a number of entities and value objects and structs and whatever you might have that together should be stored at once. By the way, if you're not using a relational database and you don't have ORM stuff that you need to deal with, the world becomes a lot easier. So we're using document databases where you can say, this is my aggregate. Here you have it. Bam. As a JSON object, it puts it in the database. Done. We don't have transactions, actually. Because actually, the transactions or the aggregate actually are very good boundaries for your microservices. Now, the next pattern. Here's the aggregate root. Every aggregate has an aggregate root, which is basically the top entry class of whatever the tree is that your domain model for this particular thing is. So if you have like an order service, it's probably the order class, which has order items, which have products. Oh, but the order items have offer items where the product definitions are, there's product properties, there's images, that stuff. That whole structure together is my aggregate, but the order is the aggregate root. Basically, it means I can only go into the aggregate through the aggregate root. And that fits exactly into microservices. So here's what you probably should do. You should investigate if you start doing this. But if you have other ways of doing this, I'm really interested, by the way. So split it up into the domains that you have, so the bounded context in which you have a single meaning for everything, and then split it up further into aggregates. This will actually work. And then each of these aggregates actually become a microservice. That doesn't mean they don't talk outside of their domain. They could, but it's not really necessary usually. And the nice thing is, it matches exactly onto how HTTP and REST actually works, right? So you normally name a service after your aggregate root. That's what we do. So we give it a name. So it's called country, right? And that means that my aggregate root is represented as a resource. Now, a resource is basically a collection of things if you talk into the REST world. So I can say, well, I need to get all the countries from here, right? Which is like 215 or whatever you have. And then you can say, well, I can find a single one of these countries through its aggregate root, being the idea of the thing which you can put on the path. And you can just say, here's country 38, which is Greece, by the way. I'm not kidding, it's actually Greece. So, and then all the other stuff that you need to get, it doesn't go on the path, but it goes into query parameters on your URL. And this fits, so all of these patterns point into the same direction. And it's really cool, it really works actually. So, step 4, which I only have 8 minutes for the rest of the 5 steps, right? But so what I'm going to do, I'm going to remove the entities from my talk and go on to the data part. So this is the next part, right? So read about entities because the entities are the core of your domain, but it's you can read that offline as well, right? So the next question is, if I have these services, what happens to my data? Now, a lot of organizations I see that move into microservices, they say, well, yeah, we cannot do that at once because we have an existing big database that the old application is still talking to. What do we do? Where do we get the data from if we start doing services? Well, the first solution they probably have is, well, this is where they come from, right? Is, yeah, well, we cannot do this all at once. So what we'll do is we'll make all these services and we'll point them to the same database, to our old database, which seems nice, but you don't solve the problem. Because the dependencies that you now loosened in your services are still there in the database. It's exactly the same dependencies, including all sorts of intermediary tables and whatever you might have, right? So you need to take the next step if you do this. You need to move into a way of saying each service owns its own data. Now, the nice thing about that is, by the way, it gives you all sorts of different problems again, right? Because you need to sort of start syncing the data from your old databases into your services. So what we do, for instance, we use Debezium, and Debezium monitors all the database changes in the old world that we have. And with every change that is useful to us, we actually trigger, we get the data in the format that our services use it, and we do a post on or put or patch on the services that we have. So we're constantly in sync with the old landscape. That is our way out. It's extremely complicated, by the way. So if you go into this direction, really think about how to do this. But your services need to own their data. If they do, then you can take the next step. And the next step is, for every service that you have, you can figure out what type of database or what type of data or where the data sits, or can I use other services as well, specifically for that service? So some services might do well on a relational database. I have no idea which ones because I haven't used any relational databases in the past 10 years, but we store mostly of our stuff in a document database, which is really, really nice, actually. But it could also be that you're talking to an identity access management system. We use Google Identity Platform for that, right? So our account service talks to Google Identity Platform. It doesn't have its own storage. Or we have a document, or well, actually an image service which takes images. We have lots and lots of images. They're stored on an S3 bucket or on a CDN or wherever they sit, right? So it's not particularly a database either. But you don't know that in the rest of the landscape. And that is one of the big benefits of having microservices. So you have this polyglot persistence. In our case, we use Mongo a lot, right? So this is not a Mongo commercial, be aware, but so we host it on MongoDB Atlas. It runs smoothly. For every tenant that we have a different database. For every collection, so for every service, we have a collection in the database. So we have a products collection, we have a customer collection, we have, well, we have a profile collection, but all sorts of these collections, you get the drill, right? And then there is a document per object. Each object in the database basically represents an instance of one of the aggregates for these services. That is a very simple mapping, again, pointing into the same direction. So that's where you need to go. So what's the next step? Now, the next step is continuous delivery. Well, even better, it's continuous deployment. If I check in my code now, which I can't because this is not my laptop, but if I check in my code now, it will be, if all my tests succeed, it will go to production in about 5 to 7 minutes, literally, right? So if you would open up the iBOOD we could actually do an experiment if I would have a longer talk, but if I would change some code, push it, and you can see the pipeline run, and eventually when it runs and it finishes completely, you will have it in the app, right? That is the speed of change that you can go for. You not necessarily have to do this. We do. So what you need to figure out is you need to pass beyond this monolithical thing, right? A lot of clients, a lot of companies, actually, they only move to production once every quarter. That's too slow because the amount of changes that you have add up. And if they add up, you need to do a lot more testing than if you would do all sorts of small changes. So the thing you need to do is you need, again, to move to smaller stuff. To say, you know, I have all these small things that I can actually put out there through the pipeline automatically all the time. Right? That is the speed of change that you need, because the smaller the changes are, the smaller your problems are, the less testing you need to do. So it's actually easier doing this than doing these big 3-month releases. So you need to move here, right? So how do you do that? Well, you need to invest heavily in CI/CD. This is one of our pipelines, actually. So you can see what it does, right? So if I check in my code, literally this happens, right? It actually builds, and then it runs the formatter. I always forget this, so I always get it back. Then the linter runs, then we run our unit test. We have unit tests for basically everything, right? Then Sonar runs on it. If my code coverage is too low or my cyclomatic complexity is too big, it doesn't go beyond this. Then we publish it. And it goes on to the development environment. So we deploy it there, we run the API test on it, and if those are correct, then we throw it to acceptance, where the load test and the performance test run, and then we deploy it to production. And by the way, these all are bootstrapped. So this is a pipeline that runs for like 5 to 7 minutes, and it's automatically there. That is the best you can do, I think. Also, I had a long discussion about this last week, actually, but like I said, no, you need to do pull requests and reviews. No, you don't. It slows you down. Stop doing that. You need to go to trunk-based development. And a lot of people say, oh, I don't believe you. I don't care. You'll get there. Eventually, I hope, maybe not. So the next thing you need to figure out is testing, right? So you need to test from day one. And testing means, so I do this talk sometimes at test conferences, right? And the problem there is there's lots of testers that use spreadsheets and then push buttons. That sort of style of testing is going to die. It has died a long way, so they've moved to automatic testing a long time ago. But you need to build it from the ground up. From the very first line of code that you write in your microservices architecture landscape, you should have the unit test in place. Because if you don't do that, you will never catch up later. And then you build the API test, and you build your scenario test, and you build your web test, and you build your end-to-end test. But it starts at the bottom. At the bottom means you need to write unit tests. There's no way around it. If you don't write unit tests, you're doomed. Because there will be a point in time that you cannot maintain your code anymore, right? So unit tests are actually very limited, because what they do is they test units in isolation. And a lot of people say to you, yeah, but it's not enough. No, it's not enough. You need to have the other layers on top of it. But it starts here, right? Isolate everything. Here's a repo being tested. I mock the gateway, or actually mock the functions of the gateway. And that is how you do it. So that means testing is everywhere on your pipeline. Testing is automated. Testing is not a manual thing. Outside for, we had a session yesterday with our customer service department because we've written some features for them. We showed them, and they were like, oh, okay, but you also do this. And we were like, yeah, tap, 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 plop. Yes, oh, that's fast. Can you also do this? Yes. So that kind of sessions you will always have. But most of this stuff is gone because you have automated it in the pipeline, in your static code analysis. So this is Sonar. We have a 79.2% code coverage on this one. I have no idea what it is. It's an account service. Good. And that means that all of this manual testing, and people say, yeah, we need to do lots of exploratory testing. Go work somewhere else, right? So it's like, nice people, but we have automated this stuff. So if you're a tester, learn how to do this. Learn how to write the code. Learn how to write the test code. And all of these accepting testing, we need 3 weeks for acceptance testing. No, you're not going to get 3 weeks because whenever you push the first button and you report the first bug, we're going to change and update it, and it'll be gone before you can retest it. This is an actual picture I took at the last time I saw an acceptance testing session. We actually did this, right? They were like, yeah, there's a bug here. And we're like, done. And like, hey, the bug is gone. Yeah, we solved it. Stuff like that. So, you need to automate the shit out of it, right? And I'm slowly running out of time, but I think I'm going to get through to this. So, the thing is here. This is W. Edwards Deming, and he says, and these are really, really wise words, right? So live by this. He says, cease dependence on inspection to achieve quality. So code inspections, peer review, stuff like that, after the code has been written, don't do it. Do it at once. Do pair programming. Mob program for the whole time. We do it a lot, actually. And the code gets the quality in the code, not after the code has been written and you're going to check this. So that means we don't do pull requests. We push everything onto the main branch. Done. Or on the trunk, actually. So that's it. And your pipelines, they build up, right? Pipelines are scripted. They're code as well. So you can extend the pipelines once they're code. And we have 3 or 4 different templates that all of our pipelines use to run. So if we want to put an additional step into the pipeline, or remove one, which we barely do, then you can do that, and it runs on all the next pipelines. So you can grow your pipeline over time. So you need to really, really take care of this. So, and you need to do this because you have a pipeline per app, you have a pipeline per service. We have like 90 of them, right? There's no way we can maintain them manually. So if you're still maintaining your pipelines manually, stop doing that. Move to automation, because your pipelines will become commodities. Now, and your pipelines will, of course, become code. So, I'll give you a short recap of this stuff. And here's the thing. Do microservices for the right reasons. There's lots more to learn that I can tell you in 40 minutes. Actually, I'm doing training courses on this, and they take a day, and lots of people say, oh, I need 2 days. I'm like, nah, I don't like training courses for 2 days. It's too long for me. I cannot keep my concentration that long. So, but remember to do it for the right reasons. You are not Netflix. You're not Spotify, unless you are Spotify or Netflix, of course. But so scalability is probably not your biggest problem, right? Figure out what the actual problem is you want to solve, and then figure out whether microservices fit that. And once you move into that direction, realize that you are probably in a complex or in a chaotic context, meaning there is no best practice. There is no good solution yet. You need to figure that out. And that is why we are in this fucking industry, because we are good at finding out stuff, right? And microservices is good for that. So this is what I figured out. You need to do really small features. So deliver features that you can deliver in like a day, 2 days, not in 3 months, right? Stop doing that. You need to run shorter cycles. We've removed everything from our process. We don't have sprints. We don't have sprint reviews. We don't have retrospectives. We don't have sprint planning meetings. We don't have Jira. Took me a long time to get rid of that one, actually. So, so we removed all this stuff. The only thing we still have left is a tech board that sets the roadmap, and stand-up meetings every day where we start the day and say, okay, we need to solve these problems today. And then people say, oh, yeah, I'll pick it up. And somebody else says, do you know, I'll join in. And we do that every day. And we do a lot of mob and pair programming. We work partly in the office, partly remote. Works quite nicely. So really shorter cycles. So the length of our cycle is actually the length of building a particular feature. And if you make the feature small, then your cycles become small, and you become faster. And you do that with smaller teams. I talked about micro teams earlier, which is a thing I invented along the way. We do that all the time in companies I work with. It works really nice. Because in smaller teams, if you listen to the ING talk on Monday, smaller teams are much more productive. And then you build smaller components. Microservices are small. Can you go smaller? Yes. Should you? I really don't know. We've tried it. It didn't fit the paradigm that I wanted to follow. And then you only have to solve a single problem per day. Now, wouldn't that be nice, right? That is a cool thing, to only have to solve one problem per day. You can actually do that if you tweak your process to do this. And if you have everything automated, and you have small components and small teams. And then, there's one thing you can never stop learning in this industry. I learn every day in this industry. I've been in it for a very, very long time, right? Maybe even before you were born. So, that's it for today. Other than that, you can find my slide deck here, and my email address, my Twitter account, my LinkedIn account. Don't hesitate to connect. And I hope you enjoyed the last day of the conference.